to state this more formally, let's think about how can we reduce the number of points we have to examine for every query made. Naturally, we can think about doing this by just throwing down more lines, which creates more partitions and fewer points per partition. So then when we go to do our query of a given point, we just need to search over a smaller set of points to return an approximate nearest neighbor. Okay, so let's think about this approach a little bit more. And what we're going to do here is very similar to what we did when we just threw down one line. We're going to take each one of our data points and we're going to score it under, in this case, each of the lines that we threw down. And then we're going to use the sign of that score to create a binary vector that's going to index which bin that point falls in. So in particular, what we see is that, for example, here, all the orange points have negative scores under line 1, line 2, and line 3. And so that's going to form a binary vector that has indices 0, 0, 0, or value 0, 0, 0. And then all these pink points, they have scores that are positive under line 2, but negative under lines 1 and 3. So that binary vector is going to have values 0, 1, 0. The blue points have values that are positive under lines 1 and 2, but negative under line 3. So it's going to have a binary vector 1, 1, 0. And finally, these green points have values that are positive under all three lines. And so the binary vector is going to have values 1, 1, 1. Okay, then we're going to take these bin values per line. So this is this bit vector that we were talking about, and we're going to think about using it to encode an index or a value in a hash table. So for example, the points that have these binary vectors with values 0, 0, 0 are going to have key values that are 0. The points that have, for example, let's say a binary vector 0, 1, 1 are going to have a key value that's 3. So it's going to take the fourth location in this table. And just as before, for each one of these key values, we're simply going to list all the data points that have that specific binary vector. So that specific set of scores under the lines that we threw down. So it's a very natural generalization of the approach we talked about where we just threw down one line. When we go to do our query, we're simply going to think about searching within the bin that query point gets scored as. And so relative to what we were doing before, though, just to reiterate, we're expecting that there are fewer points in that bin. And that's what's going to lead to our greater efficiency in doing our nearest neighbor search than if we just threw down one line.